Greetings and welcome, friends. Mr. Waddy here. We are talking about triangles of triangles. The angle, there's three of them in the triangle, and it's going to be great. And oh, just you wait, I'm going to also throw some exterior angles at you during this lesson. But here we go. Actually, I got to teach my 5-year-old the types of triangles. He knows his shapes, but he don't know these special names of them. Classifying triangles by sides and angles. So here we go. A scalene triangle has no congruent sides. There you go. Did you know that? So it's like these guys, all three non-congruent sides. Isosceles triangles have at least 2 congruent sides, which means that this next type, equilateral triangle, is a type of isosceles because of the at leastness that was written there. So 3 congruent sides are equilateral, equi-side, lateral, right, triangle. There you go. So you can also, by the way, in the future, in case you didn't know, there are shapes with more than 3 sides. And those shapes can also be equilateral, and that would be describing the same sort of thing where all of the sides happen to be congruent. Okay, classifying triangles by the angles. You can have an acute triangle. So all three, well, let's see, what was an acute angle? Do you guys remember?
Probably less than 90.
Yeah, those angles are less than 90 degrees. So all of these angles are less than 90 degrees for these 3 interior angles. A right triangle has an angle that's 90 degrees. Can it have more than one 90-degree angle?
No.
No, like if I tried to draw that, I would be like, all right, here's a 90-degree angle, and then over here will be another 90-degree angle, and then these, oh darn, and then like these connect somewhere and make the no, those are never going to cross, because actually you guys did practice, right? We know that these would be parallel lines, because yeah, those are perpendicular, and what, I don't know, that was like what, a perpendicular something theorem. I would have just taken the route of being able to show that those two are supplementary, and therefore by the consecutive interior angles theorem, those lines are parallel. So yeah, you cannot have more than one right angle in a triangle. Obtuse triangle, this angle would be, if I call it angle X, X would be between 90 and 180, okay? And I can only have at most one obtuse angle in a triangle, all right? And then an equiangular triangle has all 3 angles are congruent. And we will be able to know the exact measure in degrees of those 3 angles. There's only one situation in which those angle measures could be like that. There's only one way for that to happen. Only one. Only one. So here's a little problem. Example 1 for us. Oh, this is so great. From the world of construction, which by the way, guys, construction, I highly recommend it. I did construction in college for a little bit. It's got the problem solving. It's got like the building piece. It's got like the creative aspect. It's got the reward that at the end of the day, you're seeing something done physically. Yeah, question, comment? There is a class in this building, but not in this, I don't know, it's a separate quote-unquote school.
One of them.
Oh, I didn't even know that. Yeah, so, yeah, construction, geometry and construction. There you go. There you go. And so, yeah, I would recommend that. Classify the triangular shape. I don't know. I don't even know if I believe this is a triangle. This is like just a triangular shape. Yeah, I guess. Of the support beams in the diagram by its sides and by measuring its angles. So guys, according to the sides, what type of triangle do you suspect that will be? Isosceles, someone suggested. Isosceles, right? It's got at least two congruent sides. And measuring the angles, you could throw a protractor on that if we had it. In case you're wondering, oh, guys, I can't wait to show you this. These 2 angles are congruent. We'll someday prove that. Man, I'm so tempted to just spoil the rest of geometry for us, but
Well, since
no.
it's not,
Spoiler, it's
it's an obtuse triangle and it's equilateral. And they all just be.
Yeah.
This one's not equilateral. These ones ended up being 55-degree angles, and this one is a 70-degree angle.
Oh, well, I'm close.
All right? Yeah. Because the book told me.
Okay.
It's right there. But yeah, you could have placed a protractor on that, right? What we would have done is line up the edge of your protractor with one of those things and then measured the angle and like figured out what it said, right, Malik? That's right, Mr. Waddy. That's right. So yeah. Oh, how about this? Ooh. Can you guys do this? I don't think I even gave you space for this question, but I'm pumped about it. Can you draw an obtuse isosceles triangle? I don't know, guys. Did I? Excellent. Excellent. So, okay, all right. Obtuse isosceles triangle. Okay, here we go. So, all right, there's one of those. If it's obtuse, that means the angle's got to be bigger than 90, which looks like 90 would be about there. So let me make it a little bit bigger. Now, what I could do is swing. Whoa! I've got to turn this into a circle and not just an ellipse. Oh, that was right on. There we go. So yeah, if I want to, you could either have used a straight edge or something, but I'm just going to do one of these. So I'd mark my compass over there and then swing it around over here, and this will then be isosceles if I connect those points, because those two are congruent lengths. I think you'd agree, right? And then, oh, I almost lined that up just right. And right there, my friends, is an obtuse isosceles triangle. That's right, Lauren. That's right. And how about an acute scalene triangle? Acute scalene triangle. Right? So scalene means what now? No. No equal sides. So all right, there's one. Let's see. I got to make sure it's not 90, not obtuse. Yeah, something like around here maybe. Let's see. This is like trickier than I thought. Let's see. Well, this third side I can work with here. Let's see. At some point, right, that looks like obtuse. 90 would be right about there. So I've got to, yeah, something like this. Right, and then just make sure that if I was to measure it, that these sides are all non-congruent to each other. Wow, guys, aren't you just happy to be working with triangles? No, all right. Good times. And I don't know if you guys realize this, but triangles can also be drawn on a coordinate plane. What?
Didn't we already do like a Yeah, we did.
Yeah, I guess so, but maybe you've never thought about triangles this way. Let's classify it by sides. So in order to do that, finding the angle, finding the angle measures of a triangle. Josh, that's not your seat. You're tricking me. Yeah, but you don't need your Chromebook for this. So finding the angle measures off of a coordinate plane, Aiden, actually requires, I'm assuming they teach it to you in pre-calculus. Maybe I don't know. I don't know if we end up getting to like tangent inverse in this course or not. I don't remember. But yeah, that's actually tricky. But side length, I can determine. How can I find the side length of these? Yeah, distance formula, right? That would be easy enough. x2 minus x1 all squared plus y2 minus y1 all squared. So yeah, let's find, I'll do one of these distances. How about, I don't know, OP, overpowered, original poster, depending on, I don't know. So let's see. So this will be -1 minus 0 all squared plus 2 minus 0 all squared. And so I'll have -1 squared plus, I think you guys know how distance formula works, right? -1 squared is 1, 2 squared is 4. I get the square root of 5. Right? No? Are we good? No? And so this length is the square root of 5 right there. And I'm not going to take the time to do distance formula 2 more times. I'll just swipe from the book. Yoink. Right? And notice that you can do distance formula a couple more times. We'll compare those results. Because we are expert distance formulars. So I got the square root of 45. Actually, I would have reduced. Wow, both of those they should have reduced. But that's fine. So let's see. The square root of 5, by the way, is going to be about 2.2. So 2.2. Then let's see. Which one of OQ is 6.7? And this one is 7.1. So what type of triangle is this when classified by its side lengths? Scalene. Yeah. All right. Swish. That's right. All right. So scalene.
For it to be a right triangle, would they have to be the same?
There is a way to determine perpendicularity. And Lauren, we know that perpendicular lines form a right angle. So we do know that. And the way we figured that out was how? By comparing the slopes. If the slopes of the lines were opposite reciprocals, you could then show that there is a right angle present there. There will eventually be, you guys are likely familiar with the Pythagorean theorem. There is a converse of the Pythagorean theorem in which you can prove whether or not a triangle is acute, scalene, acute, obtuse, or right. So there is a way to do that as well later on in the future that I will show you. So guys, you already did some work on Geometer Sketchpad with some of these ideas, but when the sides of a polygon are extended, other angles are formed. Wow, did you know that? Right? The original angles are called the interior angles. I like the way that blue came out. Amazing. Interior angles, because they're on the interior of the triangle. That makes sense. And the angles formed by linear pairs with the interior angles are called exterior angles. Notice that this angle is not an exterior angle. Exterior angles would be like this one or that one. Only the ones that form a linear pair with the interior angle. Also, notice that an exterior angle, that word is not used to describe the entire angle that would form the 360 minus whatever the measure of the interior angle is. So exterior angles are very specifically designed and defined. It's like the armpit right there. Yeah, that's what it is. Exterior angles are the armpit angles of your triangle. I don't know, maybe. Underarm, is that less offensive? It's the underarm? Yeah.
I guess that works.
Okay, this is what you guys, you knew this day one. Like you were born knowing this, right?
Yeah.
You guys knew this. Yeah. We will prove this. Yeah.
Why?
Well, it's something that you've well, I mean, like Pythagorean theorem, you guys likely believe is true because you've seen it a lot. But Lauren, you might not realize this, but you've probably not ever seen a proof of the Pythagorean theorem. Yeah. So like just because you've seen something a lot. Oh, there you go. All right. So maybe you have a reason to believe it. But like triangle sum theorem, I don't think you guys have seen the proof yet. So if you haven't, just because a lot of society believes something is true doesn't make it true. So We're going to prove it today. So that sum of the measures of the interior angles of a triangle is 180 degrees, right? So measure of angle A plus measure of angle B plus measure of angle C is 180 degrees. You guys actually might even know some stats about the interior angles of other convex polygons. I don't know if you know those, like what the sum of the interior angles of a quadrilateral or a pentagon or a hexagon are. I'm assuming we might end up hitting some of those later on in the future. But here, let's prove this. Now, if I was setting out to prove this, you guys might not have known the concept of like, oh, let me just draw a line parallel through one of those points. But let's do this together. Here, so you guys, I didn't give you a little 2-column setup. Let's see, come on, there we go, wow. So let's draw our little 2 columns together, friends. Let's prove it. Don't just believe something's true because a lot of people believe it. That would still potentially make you gullible, right? Don't just believe things are true because you want them to be true, because reality doesn't often bend its will to what we would like to be true, right? Like I would like it if donuts were negative calories for me. But that's not how reality works, just because I want something to be true. Now, I do happen to be one, I've applied the theory that the longer I wait to eat a donut, the less calories it is, but I don't think that's actually true. I just like to think it's true. It's like if I wait 3 minutes instead of 30 seconds, it's less calories. But that's not true information, by the way. Statement and reason. Here we go. You guys ready? The thing you have believed to be true, we will now prove. Okay, so let's start with some given information. Yeah, a triangle exists. Here we go. This is actually an interesting start off. Draw, we've never seen one of these, BD parallel to AC.
You can do that?
Yeah, right? Like, I can just draw whatever I want. Like, you gave me a rectangle, I can extend the rectangle's sides to be lines, whatever I want. And you could imagine that being the case for any triangle that we would have drawn, right? You could draw a line parallel to the opposite side through a point. Right? If all of us drew different triangles, do you believe that this step is possible? And then more importantly, do we believe that there's only one line parallel to AC through that point? We do, and that was called the parallel postulate. Okay? All right, here we go. I'm going to say, you ready for this? The measure of angle 4 plus the measure of angle 2 plus the measure of angle 5. What do you guys think is going to be true when I add up all these angles? Is equal to 180. All right. And there's actually 2 reasons that make that true. Angle addition postulate. Could someone summarize what that was again? Yeah, if you add adjacent non-overlapping angles, they are equal to the big angle. All right? The big angle is equal to the sum of all the little pieces, the non-overlapping parts. That's what we're trying to prove. That's what we're trying to prove. So I can't reference the thing I'm trying to prove in its own proof. And let's see, then we also have the other reason that that's true is definition of a straight angle. Yeah, these ones are not ones that one does not show up often. Okay, so both of those kind of feed into that being true. All right, let's see if you guys can get this next one. I think you can. I'm going to say angle 1 is congruent to angle 4. Why is that true, friends? Alternate interior angles. Theorem. It's the theorem because I know that the lines are parallel. It's the converse if I know the angles are congruent and was proving the lines parallel. So yeah, alternate interior angles theorem. Is there another pair of alternate interior angles here that you see? 3 and 5. So yeah, I'll also say angle 3 is congruent to angle 5 for the same reason. Right? Or I could have done a ditto. Now, if the angles are congruent, I'm saying that their measures are equal. Now, who's our best friend that tells us that is true? Dave does. Or def of congruent. Def of Kong. All right? If the angles are congruent, the measures are equal. And that's also true backwards. If the measures are equal, then the angles are congruent. Yeah. Okay. Now check this. I think we're getting warm, friends. I think I can actually write my statement. I'm going to say measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. How did I do that? I think I combined this and these. Does anyone see how I could have gotten to that conclusion? Substitution. If the measure of angle 1 is equal to the measure of angle 4, then I can substitute it in for the measure of angle 4 at any time. If the measure of angle 3 is equal to the measure of angle 5, then I can plug it in for the measure of angle 5 in any equation I want to. The reason that is true, we just did substitution property, subs prop. And you got to go at least out 4 letters for that abbreviation because we also had a subtraction property and we want to be distinct. So substitution property of equality. There you go. And guys, so based on starting with just a triangle, any triangle, Lauren, we've been able to now prove that the sum of its interior angles are congruent. Good times. Good times. You guys think? Yeah, I think so. Oh, yeah. All right, and now here's another theorem coming at you, which I abbreviate as EAT. The exterior angles theorem. The measure of an exterior angle, here's angle 1, is equal to the sum of the measures of the 2 non-adjacent interior angles. So this angle right here is adjacent to angle 1. Adjacent angles have the same vertex and share a side. Okay? The non-adjacent angles would be the far away angles. Okay? Those angles are non-adjacent. And this is claiming that angle 1 is equal to the sum of those 2 angles. Does anyone have like a quick explanation as to why they think that might be true? Because of the way it is. Now, apparently there's a proof, example 42 on page 237. But what do I know about angle BA and the interior angle C? They add to 180. What do I know about angle 1 and the interior angle C? Those add to 180. So if this adds to 180 with that angle, and these two add to 180 with that angle, then these two must equal that angle. So there's my quick explanation. I think you guys believe it. So you can kind of see the structure of the proof if we were to go from there. Here, let's do example 3 together, friends. Example 3. Let's see. And I love this. I feel like we're actually getting into some application here finally, right, Lauren? So, find the measure of angle JKM. Let's see, JKM. That's this guy right here. I know that according to eat, right, that 2x minus 5 is equal to the sum of x plus 70. And now I can solve for x, which, by the way, solving for x will not answer the question they asked me, just so you're aware. It's a step along the way. So let's see, I'll bring my variables together. Oh, good old algebra. Just feels like home. Is there something nostalgic about algebra, friends? The good old days. Do you wish you could be in Algebra 1 again? All over again?
Yeah.
X equals 75. But I want to point out 75 is not the measure of JKM. That's the value of X. So what I need to do is plug that in for X to find the measure of JKM. So measure of angle JKM is going to equal 2 times 75 minus 5. So let's see, 2 times 75 I think is 150.
Yeah, correct.
So it looks like 145 degrees is the measure of JKM. Question?
You can also just add 75 to 70, so we know that J on K plus L K equal L.
Yeah. Yep, also true. Yes, I like that. Yep. Yeah. If I just added 75 to 70, that also would have worked. Very good. Let's see. Let's pick up the pace. Oh man. Guys, this is our first corollary. Have you ever, do you know what a corollary is? Are you guys familiar with Isaac Newton?
Yeah.
Isaac Newton is the dude that said, like, all of my discoveries essentially were a result of standing on the shoulders of giants. He also invented the song Head, Shoulders, Knees and Toes, Knees and Toes. But a corollary to a theorem, check this out, is a statement that can be proved easily using the theorem. So it's kind of like someone went and did all of the hard work, and then you're like, oh, you know what? You should put a period at the end of that sentence. They're like, I'm not sharing credit with you for writing my thesis for like my doctorate program because you told me to put a period at the end of this. Please. Like, I did all the hard work, and you just thought I should put a period? No. A corollary is like one small step after everyone else. No, I do not have a doctorate's degree. It is one small step after someone else did all the hard work. Okay? That's what a corollary is. It's kind of like almost, it's the postulate after the theorem is kind of what it is. So here we go, a corollary to the triangle sum theorem. Check this out. The acute angles of a right triangle are complementary. Okay? So this angle plus that angle will add to 90 degrees. Why do I know that's true? Because I know that they add all three of these, gentlemen, to be 180 degrees. And if one of those is 90 degrees, subtract 90 from both, and yeah, it kind of proves itself. It's a corollary, friends. It's a corollary. Let's see. Oh, here we go. We've got a painting. Oh, this is amazing, friends. Let's see. Is this, Lauren, is this the last example? I don't remember.
No.
Yeah, we'll see. In the painting, the red triangle is a right triangle. Okay, I believe it. I believe it. Right triangle. Shh. Ladies, gentlemen, please. All right. The measure of one acute angle of the triangle is twice the measure of the other. So if this is x degrees, this would be 2x degrees. Find the measure of each acute angle. Well, according to the corollary of the triangle sum theorem, I would say that 2x plus x is equal to what now? 90. And then I'd get 3x equals 90. Divide both sides by 3. And I'll get x equals 30. All right, so like these theorems, I love them. They're like nice and easy to apply. Some of them you already were familiar with. And yeah, we're going to do some practice problems here in just a minute. So thanks for watching, Internet friends. And thanks, as always, to our friends IRL. Bye-bye.